Alright, so this is the last part of the quiz review. So this part is section 5, where we're finding zeros of a polynomial either by factoring, or we can use long division to help reduce the polynomial to something quadratic. So I have 3 examples, and let's just talk about the basics of each of these 3 types of polynomials. This first type, I could type all of this into y equals and easily find my zeros. They all showed up easily in the table. So let's see, we have x cubed minus 4x squared minus 7x plus 10. So when we look at our graph of this polynomial, let me go back to my regular window. It looks like it's touching at like regular tick marks. So -2, 1, and 5 look hopeful here. So we can look at our table and check to see if those are exact, and they are. So we have -2 is where y equals 0, 1, and 5. So those are really straightforward. We can just check the table. They were very exact values. They're in the table where y equals 0. If we had to write them in factored form, we could do that by just changing the sign of each one. So that type is really simple to do in the calculator. There'd be no need to do a whole lot of extra work for that one. The second kind, we had 3x cubed minus 3x squared minus 4x plus 4. The zeros, just by looking at these, and I'm just jumping ahead here, like these are not going to all factor. So I could not have used this method for the second example. So what I could do is group it, and it did work to group, and I took out 3x squared of the first 2 terms, and I took out -4 from the second 2 terms, and then I had 3x squared minus 4, x minus 1 are my factors, but when I set them equal to 0 and solve to get the zeros, I get x equals 1 pretty easy, but then this one just needed a little bit of work. I did 3x squared minus 4 equals 0. I added 4 to both sides. I divided by 3, but then I needed to get rid of the square on the x. So I took the square root of both sides, and that gave me plus or minus the square root of 4/3, which I could rewrite as plus or minus the square root of 4 over the square root of 3, and then the square root of 4 would simplify to just be 2. But then I need to get rid of the square root of 3 in the denominator. So I rationalized my denominator by multiplying the top and the bottom by the square root of 3. And that left me with plus or minus 2 square root 3 over 3. So that certainly is irrational. It would not have just been an easy one to find on the calculator. It would have given me a decimal, but for instance on like the SAT or the ACT, they usually write them in this form. And then you have to play the whole like decimal matchup game, and that takes time that you don't need to take. So this one had 3 zeros, roots, solutions, x-intercepts. Remember, those all mean the same thing. Now the third example, we can find an x-intercept in the calculator at x equals -1. So if we plug it in, we check our table the way we did this one, we would have found that y equals 0 in our table at x equals -1. And then we could use that to set up a divisor. So if x equals -1 is an x-intercept, then b plus 1 would be a factor of this polynomial. So I know that I should come up with no remainder even before I start the problem, because I know that that is a factor because that was an x-intercept that coordinated with it. So then I did my long division. So just to walk you through like the first couple steps, I won't do every single step, but in case you need to review this method, I had to figure out what would multiply to give me b, and multiply times b to give me 2b cubed. So that would be 2b squared, and I wrote that at the top. Then I take 2b squared times b, and I got 2b cubed and wrote that down. And then 2b squared times 1 is 2b squared. But then you subtract both of those terms, so you can think of it as subtracting or change the sign of them, whatever's easiest for you to think about. And then the first 2 terms should always cancel out, and you bring down what's left. So -4 and -2 would be -6b squared, and I just brought the rest down. So then I think about b times what would give me -6b squared. and that would be negative 6b. So I wrote that at the top. Then negative 6b times b is negative 6b squared, and negative 6b times 1 is negative 6b, but then I subtracted both, so that's why my signs changed right there, and then those first two would cancel out. And then you continue that process and you end up with no remainder. And like I say, you know you needed no remainder because you definitely had a factor to start with. But then what's left over is a quadratic function that we still need to finish solving because our goal was to find all the zeros of the polynomial. And so I brought that down here where I had more room, and I set it equal to 0, and I noticed it would not factor, so I divided everything by 2. That's how I simplified to get b squared minus 3b minus 3 equals 0. And then I just plugged it into the quadratic formula. So negative b was 3 plus or minus b squared minus 4ac all divided by 2a. And then I simplified all of that to get 3 plus or minus the square root of 21 all over 2. And then I put everything together over here. So I have 3 zeros, which makes sense because I do have a cubic function. I have a 0 and negative 1. Remember, that's what we started with, so you don't want to forget that one. And then I have 3 plus the square root of 21 over 2 and 3 minus the square root of 21 over 2. So these are 3 different ways you can find all the zeros. You can type it in the calculator, you can factor it and then set your factors equal to 0, and you can use an x-intercept to get you started and reduce it using long division, and then take what's left and either keep reducing it until you get a quadratic, or go ahead and take the quadratic function and use either factoring, if it would be possible, or quadratic formula. But if factoring were possible, you'd probably have already used that method. So that's it for those.